session of Ming's classroom. Today we talk about number system. Well, as you know, in mathematics, numbers are the basic building blocks of mathematics, or one of the basic building blocks, because when we count, we need numbers. Now, we have this number 1, 2, 3, 4. This is what we call counting numbers. So, we'll put here, counting numbers. They are also called natural numbers. Well, right, natural numbers. And reason is that 0 usually is not considered as a counting numbers, right? In the IB, International Baccalaureate, 0, 1, 2, 3, 4 is actually called the natural numbers. Well, there is a bit of a controversy here, because in some country, natural numbers is 1, 2, 3, 4, as in Japan. This is just 1, 2, 3, 4. But in the IB, this natural number includes actually 0. And the symbol for natural number is n. It's n like this, with a little line here, the script n, right? So here's the counting number, and here's the natural numbers. Now 0, you think that, well, why is it not counted as a counting number, or why is it not considered as a counting number? Well, because in the past, well, you can count 1 sheep, 2 sheep, or 1 cow, 2 cows, 3 cows, and so on, but never count 0 cow. In fact, this concept of 0 never really spread to Europe until the Middle Ages, and only later it was accepted in Europe. So this concept of 0 is actually very interesting. Right. We also have -1, -2, -3, -4. If you put -1, -2, -3, -4, this is what we call negative integers. And it's represented with integers are represented with a z. And because it's negative, you put a negative sign at the upper hand corner here. And obviously, you can say, well, what is 1, 2, 3, 4? Isn't this integer as well? Yes, those are also integers. Therefore, they are called positive integers, and denoted with a z with a plus sign. These are positive integers, and these are negative integers. You have the negative integers and positive integers and 0 added together. This system of numbers is just simply called integers. So now without the plus and negative sign, right? Just integers. So these are the integers. Well, if you have two integers, one integer here and another integer here, 2 integers, and you add 2 integers up together, let's say 2 plus 7, then you get 9, which is also another integers. The 2 integers, and you subtract 1 integer from another, let's say 2 minus 7, -5, that's also an integer. So when you sum or add integers together, you always get an integer. And how about multiplication? So if you have 2 and here's 7, 2 times 7 is 14. That's also an integer. Therefore, when you have 2 integers, you take the product of them, it's also an integer. Having said so, if you have 2 divided by 7, well, that's not an integer. This is a ratio, right? You can call this a fraction, right? You can call this a fraction. Basically, this type of numbers, fraction here, are called rational numbers. Rational numbers. Here, the rationals here come from being a ratio. It doesn't mean that these, are more sensible than others. It means just that these are a ratio. A rational number composed of A over B, where A is an integer and B as well is an integer. So here's an example, 2 over 7, a fraction as an integer. Alright, how about 0.3? Is that an integer? Well, that's also an integer because 0.3 can be written as 3 over 10. So that's an integer. How about 0.333 and repeat itself forever? Well, this number actually, when it's repeating, the repeated decimal here can be written as 0.3 with a dot on top. That's the way the Japanese like to write it. Or 0.3 with a bar on top. I prefer the bar. The reason because if you have something like 0.257 and 257 is repeated, for example, then for the Japanese system, with the dot system, you have to write 257 with 2 dots. It is. This is where it starts and this is where it ends. Or better still, write it as 0.257 with a bar on top. It means that 257 is the number that repeats indefinitely afterward. So these are numbers and fractions. These actually are called rational numbers. I'll explain in another lesson why these are rational numbers. Okay? So when you have integers and rational numbers, well, if you have rational numbers, there are also numbers which are not rational. They are called irrational. For example, square root of 2 is irrational. That means, what it means is that the decimal expansion at the end does not repeat itself, and it doesn't end at a particular value, like 0.3 here. It ends at a particular value. This is repeating by itself. So 0.2 is an irrational number. Here's another one which is irrational. Pi is irrational. Right? Square root of 3 over 7, that is also irrational. All these are irrational numbers. Now, is there a symbol for rational numbers? Actually, there is. Usually we use Q for rational numbers, and then we use Q with a bar on top as irrational.